Long, long ago, in good olden days, when we used to have very simple computers, then those computers were capable of executing instructions in a serial manner only. So, first they would execute instruction number 1, then 2, then 3. What I mean by that is they could not move from one instruction to some other instruction by skipping few things in between. That was not possible. But as the world has evolved, it has become possible. And that is the reason if you buy a laptop and bring it to your home, you can see that on one hand, you can load a web page on your Google Chrome browser. And parallelly, you can also open some calculator app where you can compute your monthly expenses. Both these things can happen in a together fashion. Okay. Now, how does it happen? Let's get back to the basics. So if you load a web page on your Google Chrome, what really happens is that you need to wait on the internet for some data to be transferred from one server to your computer. So you're basically waiting over the network. While that wait is in progress, it can very well happen that your CPU can focus on the calculations that you are doing on your calculator. Right? See, now there are two possibilities here. The first possibility is if your CPU had two processors, in that case, first processor would have solely focused its job on the web browser and second processor would have focused on your calculator app, right? But even if you just have one processor, it can be done. Why? Because that first processor, while your web page is getting loaded and you're waiting over internet, it can switch its focus on your calculator app, right? So guys, I have just illustrated two scenarios. And to make it very, very clear, the first scenario where you had two processors, both were dealing with things parallelly, that is parallelism. But the second scenario where you just had one processor, which was doing nothing but it was time slicing the tasks, that is called as concurrency. Now, I used a very important phrase over here, time slicing the task. What I mean by that is, let's say you have got multiple tasks, task A, task B, task C, task D. And let's say you just have one processor. What that processor can do is, it can allot first 2 seconds to task A, next 3 seconds to task B, next 1 second to task C, next 4 seconds to task D, and then again it can come back to some other task, allot it some time, and then go back, switch to some other task, allot it some time. So do you see what is happening? There is just one worker. There is only one processor. But there are multiple tasks and all of them are happening concurrently. Why they are happening concurrently is because we are allotting different chunks of time to all of them. Your computer also behaves in this manner. So even if you have a computer which just has a single CPU core, it allows you to perform multiple things at a time. How? This is what it does. So because there is single processor, it does not perform two or more than two things at the same time. It can only perform one thing at a time, but it switches from one task to the other task to yet another, and it gives you an impression as if things are happening parallelly. But in fact, they are happening concurrently. So this is a key difference that we all need to be very clear about in parallelism and concurrency. If I have to give you a much simpler idea, what I would say is, let's say you go to a kitchen and you see that there are certain carrots and certain radishes. So if you want to cut them, then the first option for you is, let's say you can use your right as well as left hand. So by right hand, you can cut the carrots and by left hand, you can cut the radishes. So here you are cutting the vegetables parallelly. But if you just can use your right hand, in that case, for first 10 seconds, you can cut carrots. For next 12 seconds, you can cut radish. And then again, you can come back to carrot. Again, you can go back to radish. So somebody who just looks at the vegetables that have been cut will get an impression as if they are being cut in a parallel mode. But in fact, that is not happening. So this is what concurrency is, in which you allot different slices of time to different tasks. You do not actually do them at the same point of time. This is important. Okay, one more thing. These days, computers have evolved and we have multiple cores, we have multiple processors. Because we have multiple processors, it is possible to do things in a parallel mode also. And as we progress ahead in the course, you will realize that if we write a program which is concurrent, and if our computer has multiple cores, then few instructions can be processed in a parallel fashion also. Cool. So I hope now you guys are very clear about the major difference between parallelism and concurrency.